In this video we're going to see some limits with exponential functions, and to do this easily we'd better be familiar with some basic limits, like the limit at negative infinity of e to the x is 0, at positive infinity of e to the x is positive infinity, the limit at negative infinity of x to the n e to the x is 0, the limit x goes to positive infinity of ex over x to the n is positive infinity, because e to the x is very strong. When x to the n is large, this is infinitely larger, so we get positive infinity. And the derivative at 0, it's the limit when x goes to 0 of ex minus 1 over x is 1. So let's start with the first example. When we have a limit like this, we need to factorize by e to the x, or if we have a higher power, we factorize by the e to the highest power. So it's the limit e to the x times 1 plus 3 over e to the x, e to the x factor 1 plus 1 over e to the x, limit at positive infinity. So e to the x cancel out, and if we plug in positive infinity, this would be a 0 and this is 0. This is a 0, because e to the x at infinity is infinity, 3 over infinity is 0, and we're left with 1 over 1. The second example, we need to factorize by e to the 2x, limit at negative infinity, e to the 2x times 1 plus 3 over e to the 2x, and e to the 2x times e to the x over e to the 2x, so it's 1 over e to the x plus 2 over e to the 2x. This will cancel out, and as before, this is a 0, this is a 0, because e to the 2x, this is infinity, e to the infinity is infinity. So this is a 0, and here too, it's a 0, and here we have a 0, so it's 0 over 1, which is 0. The third example, here it's the limit when x goes to positive infinity. Here we can divide this and have two fractions, so it's ex over x to the 4th plus 2 over x to the 4th. Clearly this is positive infinity, and this is a 0 at infinity. Here we said that e to the x over any power of x is positive infinity. So it's positive infinity plus 0, which is positive infinity. Next one, here it's clear that we gotta factorize by e to the x. E to the x times 3 plus x, e to the x, and e to the x times 1 plus 2 over e to the x. This will be simplified, and this is a 0. X over e to the x is 0 because this is stronger than this, and here is 0. So we're left with 3 over 1. The last one, to get rid of the square root, we need to multiply by the conjugate, which is square root of e to the x plus 1. Ex plus 1 over x times, I need to multiply by the same number here, I forgot the limit at 0. So here, if we FOIL, we get the e to the x, square root of e to the x all squared is e to the x, minus 1 squared, which is 1, over x times square root of e to the x plus 1. I keep forgetting the limit at 0. Now it's the limit of e to the x minus 1 over x times limit of 1 over square root of e to the x plus 1. This one at 0. This one is, we have it here, it's 1. So it's 1 times here, if I plug 0, e to the 0 is 1, square root of 1 is 1, 1 plus 1 is 2. 1 over 2, and it's 1 over 2.